Okay, so Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Alright, so this is a video to cover for lecture about topic limits and continuity. Okay, so this is our second last topic about limits. So first we go into limits. Okay, so limits is basically used to describe how function behave. Okay, let's say we have a function, graph function like this. Okay, so let's say down here we have x with equal to 2. So limit is basically when we say limit x is approaching 2, means we have a number of x value that is getting closer to value of 2, and it happens on both sides, and there is approaching di sebelah kanan dan ke sebelah kiri. Alright, itu ada sedikit mengenai limits. So kita akan pergi kepada properties of limits. Okay, then let's say we have limit x is approaching to the value of c, and right here is a function of k. So in order to find the limit of function k, that where the x is approaching the value of c, we need to substitute the value of x into the function. Okay, since that the function has no value of x, so limit k just equal to k. So if we have limit x is approaching to c and the function is x, so then we substitute the value of c into the equation. So it is equal to c, and if we have limit x is approaching to c, x power of n, so it becomes c to the power of n. And let's say if we have limit x is approaching c, square root of x n, and it just equal to nc. Okay, so now let's look at the example, the actual example for limit. Let's say we have limit x is approaching to 1, and the function is x squared minus 2x plus 3. Okay, then in order to find the limit of x approaching to 1 in this function, we need to substitute the value of 1 into the function. So then we have 1 square minus 2, 1 plus 3. So then we have 1 minus 2 plus 3, and then we have it equal to 2. So this is the value for limit approaching 1 of function x square minus 2x plus 3. Alright, then let's look at another example. We have limit x approaching 2 of x square minus 5 and x plus 1. So we substitute value of 2, then we get 2 square minus 5, 2 plus 1. So then we have here is negative 1 and 3, and we get the answer is negative 3. Alright, and then let's look at about one-sided limit. This is about one-sided limit. So let's say we have limit of x is approaching a. So limit of x approaching a, fx equal to L, it can be divided into two types of limit, which is first, limit x is approaching a from the right of fx, and limit x is approaching a from the left. So that's why this is called as one-sided limit, and both of these will be equal to L. So for example, let's say we have limit of x approaching to 0 of graph x square. So basically, by graph, the function of x square touches the origin and goes up. So this in the middle is the value of 0. So where the limit of x approaching 0 from the right means the value of x is approaching 0 from the right side of the graph. Then for limit x approaching 0 from the left means the value of x is approaching 0 from the left side of the graph. Okay, sometimes the answer will give the same number, but sometimes it will be given a different number. Okay, both akan ada dia punya condition sendiri lah nanti. Itu kita akan tengok kemudian. Okay, then this is the statement. Limit x approaching a, fx exists if and only if limit x approaching a from the left, fx equal to L, and limit x approaching a from the right, fx equal to L, exists and equal. Okay, apa yang statement ini masukkan adalah, macam saya cakap tadi, kita ada limit yang kiranya ini adalah limit yang general, yang mengandungi semuanya. So daripada sini dia akan ada limit x approaching a from the right, fx, dan limit x approaching a from the left, fx. Okay, explanation atas ni dia nak cakap bahawa kalau limit x approaching a, f from the right, fx is equal to limit x approaching a from the left, fx. Okay, kalau if both of them are giving the same answer, means ia bermaksud bahawa limit x approaching a, fx exists. So syaratnya dia kena limit x approaching a from the right exists and equal to limit x approaching a from the left exists, barulah limit x approaching a, fx tu akan exist. Okay, itu syarat-syarat dia. Okay, dan apa maksud exist dengan tak exist ni adalah dari segi grafnya. Dari segi grafnya, let's say kita ada dua graf. Ini adalah contoh kat sini. Ya, ini adalah contoh di sini. Okay, kalau macam ni, so let's say ini adalah limit x approaching 2 from the left, and this side is limit x approaching 2 from the right. So bila masa x axis tu approaching 2 from the right, dia akan mewakili graf di atas ini, sebab kawasan ini sahaja graf yang atas ni berada di kawasan yang besar daripada 2. So apabila limit x approaching 2 from the left, dia akan mewakili graf yang ini, sebab graf ini berada di bawah nilai 2. So bila dia sama dengan 2, dia akan memberi nilai yang berbeza. Bermaksud ini contohnya 5, ini contohnya 1. So limit x approaching 2 from the left is not equal to limit x approaching 2 from the right. So means yang ni not exist. Senang kata adalah dia ada 2 titik di sini. So dia tak boleh ada 2 titik. Sama macam awak test function itu, sama ada function itu exist atau tak exist, adalah bila awak buat test dengan vertical line tu, dia tak sepatutnya intersect with more than one point. Okay, contoh kalau graf itu exist, contohnya adalah kalau graf macam ni 2. So this is limit x is approaching 2 from the right, and this is limit x is approaching 2 from the left. So ini coming from the left and coming from the right. So bila dia sampai dekat 2, kita dapati, kita tengok dia both are showing the same answer. For example 3. So yang ini means limit x approaching 2 does exist. Maksudnya dia bersambung, dia tidak ada gap di antara dua-dua graf tu, dua-dua belah kiri dan kanan. Okey. Contoh lagi, kita try satu contoh soalan, iaitu finding existence of limits. So let's say we have function f(x) equal to a type of piecewise function 3x plus 3 and x square plus 5. So the condition is 3x plus 3 if x is less than 2, if x is equal to 2, and this one if x is bigger than 2. So itu condition dia. So to determine whether the limit exists or not is that we need to try the limit on both sides for x equal to 2. Means we need to do x approaching 2 from the right. So since we want to find x approaching 2 from the right, so we need to choose this equation, because this equation, it consists the region of x is bigger than 2, and then our limit is also coming from the right, which is the number bigger than number of 2. So then we choose x square plus 5. So then we take 2 square plus 5, we get here is 9. So that is for limit x approaching 2 coming from the right. So now let's try for limit x is approaching 2 coming from the left. So from the left we have to choose this equation, because the equation consists of a number less than 2. So we take 3x plus 3. So equal to 3, 2 plus 3, so equal to 9. So both from the right and from the left showing the same number. So this means the function, no sorry, not function, means limit x approaching 2 fx does exist at x equal to 2. So now let's try another example, is to find limit x approaching 3 fx. So fx is equal to 3x minus 4 x square. X is less than 3, x is bigger than equal to 3. So for limit x approaching 3 from the right, a is equal to x square. So means 3 square equal to 9. So for this one, limit x approaching 3 from the left is 3x minus 4 equal to 3. 3 minus 4 equal to 5. So we can see here that 9 and 5 not same. So we can conclude that limit x approaching 3 of function fx does not exist. Alright, and then let's look at the next section. The next section is about computation of a limit using algebraic technique. Okay, so when we are substituting the value of limit into the function, there are actually two conditions where cannot be satisfied in this chapter, okay, or even in mathematics. Okay, the two situation, apa saya cakap tadi, two things, two situation yang that cannot be satisfied in this chapter is when we get the answer is 0 over 0. This is the condition number 1. And for condition number 2 is that we have infinity over infinity. Okay, so these two condition cannot be met in limits. Okay, maksudnya dua kondisi ni, 1 dan 2 ni tidak boleh berlaku di dalam kita punya jawapan untuk limit. Okay, ini dua ni adalah dilarang sama sekali. Okay, jadi ada cara untuk mengelakkan berlakunya 0 over 0 ataupun infinity over infinity di dalam limit. Okay, cara itu adalah, yang pertama, A adalah dengan menggunakan cara factorization, and cara yang kedua is multiplication with conjugate. Okay, so now let's look at an example. Find limit x approaching 1 of function x square minus 6x plus 5 over x minus 1. Okay, section ni maksudnya dia adalah untuk bahagian yang adalah fraction, yang mana dia adalah fraction. Okay, contoh, kita ada limit x approaching 1, x square minus 6x plus 5, x minus 1. So if we substitute the value of 1 into the function, and then we get x square, 1 square minus 6, 1 plus 5 over 1 minus 1, and here we get 6 minus 6 over 1 minus 1, here is 0 over 0. So this is the thing that I spoke before. that we never should ever get x 0 over 0 or infinity over infinity. Okay, the method to solve when we encounter this kind of situation is to apply factorization on the function. So then we have limit x approaching 1, and we need to factorize the x squared minus 6x plus 5. So then we have x minus 1, x minus 5 over x minus 1. So this can be removed. So then we have x minus 5. Only then we substitute our value of limit. So 1 minus 5 is equal to negative 4. So that negative 4 is our acceptable answer. Alright, then let's look at the next section, which is not next section, next question. Find limit x approaching 0 for function 1 over 2 plus x plus minus 1 over 2 over x. So if we substitute the value of x directly into the function, then we will get 1 over 2 plus 0 minus 1 over 2 over x. So then we have 1 over 2 minus 1 over 2 over 0, and finally we get 0 over 0. So once again, we made a condition that should never happen in limit. So in order to do this adalah kita buat limit x approaching 0. We try to equalize the denominator of the numerator, okay, which is 1 over 2 plus x multiplied with 2, both pun multiply with 2, minus 1 over 2, 2 plus x, 2 plus x over x. So then we get 2 minus 2 plus x over 2, 2 plus x over x. So then we simplify 2 minus 2 minus x over 2x, 2 plus x. So then we get negative x over 2x, 2 plus x. So x can be removed, and then we get negative 1 over 2, 2 plus x. Okay, then we substitute the limit x equal to 0. So negative 1 over 2, 2 plus 0. So then we get negative 1 over 4. Okay, now let's look at another example. Is find limit x approaching 3 of square root of x minus square root of 3 over x minus 3. So if we substitute directly, we will get square root of 3 minus square root of 3 over 3 minus 3 is equal to 0 over 0. So when this cannot be done, so we need to use another method in order to find the limit of x approaching 3. So the method is called the conjugate, which is the second method that I just tell you before. The conjugate is used when you encounter a fraction and one part of the fraction, either numerator or either the denominator, has square root in it. Okay, for example, here we have square root in the numerator. So what we do is we take limit x approaching 3 square root of x minus square root of 3 over x minus 3. We multiply the fraction with the conjugate. So this is the conjugate. The conjugate is like a mirror to the fraction. Okay, so kita ambil yang ada square root je. Yang tak ada square root tak payah. Kita ambil yang ada square root, dan kita ubah dia daripada negatif menjadi positif. So then we solve square root of x minus square root of 3 square root of x plus square root of 3 over x minus 3 square root of x plus square root of 3. So from here we will have x plus square root of 3 square root of x minus square root of 3 square root of x minus 3 over x minus 3 square root of x plus square root of 3. So kita sambung, solvekan dia. So ini akan jadi 0. So then we have x minus 3 over x minus 3 and square root of x plus square root of 3. So ini akan boleh dibuang. So sama dengan 1 over square root of x plus square root of 3. So then we substitute the value of limit into the function, which is limit is equal to 3. So then we get here is 1 over square root of 3 plus square root of 3. Then we get 1 over 2 square root of 3. So that is the answer of the limit for that function. So now let's look at another example of limit. Find limit x approaching 2 of x squared minus 4 over x minus 2. So this can be factorized. That will be equal to x plus 2 x minus 2 over x minus 2, which can be removed. So we have here x plus 2, so equal to 2 plus 2 equal to 4. So let's get one last example for this section, which is limit x approaching 0 of 1 over 4 plus x minus 1 over 4 over x. So this can be simplified. X approaching 0, 1 over 4 plus x multiplied with 4 minus 1 over 4, 4 plus x, 4 plus x over x. So then we have 4 minus 4 plus x over 4 plus x over x. So then we get 4 minus x over 4x, 4 plus x. So we have negative x over 4x, 4 plus x. So x can be removed. So we are left with negative 1 over 4 plus x. So that we get negative 1 over 16. Oh, ada lagi satu contoh. Tak pasal pula Contoh mengenai conjugate. Find limit x approaching 6 of square root x minus 2 over x minus 6. So we need to do conjugate for this. So it will multiply with x minus 2 plus 2 over x minus 2 plus 2. So then we have x minus 2 x minus 2 minus 2 and x minus 2 plus 2 over x minus 6 x minus 2 plus 2. So dari sini kita akan ada x minus 2 plus 2 x minus 2 minus 2 x plus x minus 2 minus 4 over x minus 6 square root of x minus 2 plus 2. So this can be removed. So then we are left with x minus 6 over x minus 6 square root of x minus 2 plus 2. So this also can be removed. So then we are left with 1 over square root of x minus 2 plus 2, then literally equal to 1 over square root of 6 minus 2 plus 2, then we have 1 over 2 plus 2 equal to 1 over 4. So that is our answer for that limit. Okay, now we go into next section is for limit of absolute value function. Okay, so let's say we have a limit of x approaching 0 for modulus of x. So we know that when we have a function for a modulus, so means there will be a positive and a negative of that function. So means this function limit can be separated into two. One for positive x and another one for negative x. And for the positive x, the limit becomes x approaching 0 from the right side, because positive x is on the positive region. So that's why x is always approaching 0 from the right side. For negative x, it will be limit x approaching 0 from the left side. So macam tu lah So dari segi grafik, this is 0. So x yang positif akan datang daripada right side, meanwhile x for negative akan datang from the left side. Okay, so now let's look at the example of limit x approaching 2 from the right side of function 1 over modulus 2 minus x. So since we have 1 over modulus 2 minus x, and the limit wants to find the value of x approaching 2 from the right side, so we need to consider modulus for positive only, because 2 coming from the right side. So it will be equal to limit x approaching 2 from the right side over 2 minus x. So then we have 1 over 2 minus 2 equal to 1 over 0. So then it equal to infinity. So let's say we have another example. Limit x approaching 3 from the negative from the left side. So x minus 3, modulus of x minus 3. So it will equal to limit x approaching 3 from the left side of negative x minus 3, because x is coming towards 3 from the left side, so that's why we need to consider the negative for the modulus. So negative 3 minus 3 equal to 0. And another example is limit x approaching 0 for modulus of x over over x. So this, sebabkan dia tak bagi tahu coming from the left or from the right, so we need to consider both situation. So limit x approaching 0 from the right side is positive x over x, while limit x approaching 0 from the left side is negative x over x. So x over x can be removed, so it will be equal to 1. So this it will be equal to negative 1. So when we have a limit from right and left side equal to different number, not same number, so what we have learned before taught us is that the function of limit x approaching 0 over x does not